Okay, we're going to look at some transformations of the graph of sine x, y equals sine x. And in the upper right over here, I included all the formulas, pretty standard notations. You know, sometimes they might switch the letters up depending what resource you use, but most often I've seen the A, B, C, and D here. Now, I also want to relate this to just using transformations like from maybe a college algebra class that you've seen with any quadratic or cubic. You take a parent function and then you use transformations, right? So looking at this first one, 2 sine half of x. This 2, we would call that a vertical stretch because it's multiplied to the entire function, right? We have sine x as the parent function, and then multiplied by 2, we'd vertically stretch it, where anything that is, I say, within the function, so this 1/2 is part of the function, right? Sine x, sine 1/2 x, is a horizontal stretch or shrink. Anything horizontally is also, you could typically think of it as backwards. Like I would expect 1/2 to shrink that, but in fact, horizontally, it would stretch it. Now, trig though is slightly different because we have this function that's periodic and right, we know it has a sine wave and it repeats the standard one every 2 pi is a full rotation. So how exactly do we apply it here, right? So let's take a look. So the vertical stretch, what we call now, is the amplitude. Okay, this a, whatever number is being multiplied to that sine or cosine, it has the same rules, just different starting points. So I know the amplitude is 2. Now notice the absolute value. It's because if there were a negative, we're talking about a reflection here, right? That's going to just flip the function around the x-axis, that in that direction. So amplitude is always positive because we're talking about a distance, how high this function goes from what we'd call the midline. Now, I don't have a minus c or a plus d in this first example, so therefore this 1/2 is our b. So if we look at period, right, we take 2 pi and we divide it by b, which is 1/2, or in other words, 2 pi times 1/2 is 4 pi. So like I said with the horizontal, right, you want to actually kind of think backwards in terms of knowing what's going on with that graph. It's stretching it because before we would complete one full period and from 0 to 2 pi, now we take up to 4 pi. Another way of thinking of this number in here is it'll complete now 1/2 of a cycle within the standard 2 pi. So those are some of the basics. Where it starts to get trickier is, all right, so this 3 here, right, does that mean we have 3 full cycles from 0 to 2 pi, and is that a right shift of 21? Or, and same thing with even a parabola there. Once you have multiple things going on, sometimes it's just best to kind of reassess, rethink, and check a few points. Okay, but we'll do that example here in a second. So I don't have a c, and even if you use this formula, right, 0 over 1/2 is 0, so the phase shift is 0. That means it wasn't shifted left or right at all. And I don't have a d, so it wasn't shifted vertically either. So graphing this, because there was no shift left or right, I can still just go from 0 here, right? That's my first point. Now the amplitude is 2. What does that mean? So sine used to go 0 to 2 pi, right? We said now this period is 4 pi. So I know it's going to do one full cycle, 0 to 4 pi. And because it's periodic, it starts at 0 and ends at 0. For cosine, it would start at 1, end at 1, or in this case, amp is 2, so it'd start at 2. So now, because amplitude is 2, think of that as like a vertical stretch, right? We're going to go up to 2 and down to -2. Now let's go ahead and, how I like to graph sine is find the midpoint here, because we're going to head up and then down in the middle, down to -2 here, right? And that would be our full cycle. So let's finish filling that in. Between 0 and 2 pi we have pi, and here's 3 pi. Okay, we don't need a ton of points in here, right? Enough to kind of see what's happening. And I know, if I went the negative direction, because we really like to see 2 full cycles. It makes it nice and clean. Okay, and I could kind of do this pattern backwards. I would end at -4 pi, somewhere here at -2 pi. I would hit the minimum at -2 and the maximum of 2 right there. And I draw these arrows at the end because it does extend indefinitely. Right? Okay. So some other questions to consider is like domain and range. So let's see, we'll stick with blue. Domain is -infinity to infinity. There is no restrictions, right? The range is from -2 to +2. And I think that would be all that we would consider looking here. Let's see. Oh, maybe the midline. We might want the midline. We have the maxes and the mins. We stayed the domain and range. We found the amplitude, period. Yeah, so the midline is simply this didn't have a vertical shift, right? So here's our midline there. We could give that an equation, just y equals 0. Now, while I have this graph, I'm going to also, we'll do it in pink, I guess. Consider this function. Okay, 2 cosecant 1/2 x. So the reciprocal function. We had talked about doing this graph, and let's throw one more color in here. We'll do greens for the asymptotes. Anywhere where sine crosses the midline, and in this case there was a vertical shift. So here, 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 and here for my 2 periods would be vertical asymptotes for cosecant. So if I had asked you to graph this originally, I would actually just graph 2 sine ½ x and then fill in where cosecant would go, because cosecant occurs at each max. Right, we have kind of this parabola looking thing, and it extends vertically along them asymptotes there. Now, we wouldn't really say the amplitude here, but it does have the same period. Domain, we have some restrictions, and the range is kind of the opposite, right? So what changes here is just the fact that our domain, many ways to write this, but notice it can't be 0, x cannot be 0, 2 pi, 4 pi, 6 pi, and so forth. So I would just state something, x cannot be plus or minus 2 pi k, where k is any integer. Or we could even just say 2 pi k, let's do that. 2 pi k, where k is an integer. Okay, So that means k could be -1, -2, or 0, or 1, or 2, and so forth. The range is now, we go from -infinity all the way up to 2, and we include 2. To -2. Union, and then we start back up again 2 to infinity. All right, that takes care of that one. Let's look at this next one, which the graph may be a little more challenging, and probably, on something like this, you're going to go ahead and want to use technology, use a graphing calculator or GeoGebra to assist you with a better looking graph, because we can only do so much by hand when it starts to get kind of ugly here. Okay, I will go ahead and do most of the work here in green to separate it from the first one. So let's start with the easy thing. Here's our amp. Okay, our amplitude is 2. Now, the period is 2 pi over b. So we have 3 here. So the period, amp is 2, is 2 pi over 3. And then the phase shift, so this is our variable c here. So I'll just put ps, phase shift. We do 21. Notice there is a negative there, right? So we don't count the negative. C is positive. So 21 over 3, which is 7. And then we have a vertical shift, which is equivalent to D here. So there's our vertical shift is 4. I'll just put VS, vertical shift. Okay. So, like I said, graphing this thing, let's get it black, it's going to be a bit tricky, right? How do you really graph this? So, we have a period of 2 pi over 3, phase shift of 7. So I'm just going to start 0 over here somewhere. And let's go right 7. Okay. Now I put a dot just kind of, I may end up erasing it. This kind of just gets me going. So there's 7 because I had a phase shift of 7. So this whole graph got shifted to the right 7. Okay. Now we also went up 4. So again, I put that kind of too quick. So I'll just erase that. Ooh. There we go. All right. Over 7, up 4. And from here, I have a period of 2 pi over 3. So here's what I was saying. I mean, how accurate can you be? Because 7 plus 2 pi over 3. I mean, if I were to round, it's a little over 2, so it's going to be 9-ish, right? But I don't know. 7 plus 2 pi over 3 is where my period ends. And then same thing if I wanted 2 full cycles, right? I'd go back 2, so somewhere here, hard to say exactly. And again, get a good rough sketch, verify it with a technology. So now the amplitude we have is 2. So we'll go in blue still. So amplitude is 2. So that means I'm going to go up 2, right, and to the middle, and then down 2. So down here to 2. And I'm freehanding, so it's even worse. Okay, without graph paper. Same thing here, let's find the middle, somewhere there, the min, somewhere here, max, somewhere there. Okay. Now, if you wanted it centered at 0, right, we could kind of just follow along and trace it, again, verify with GeoGebra or whatnot. What I wanted to talk about, though, really quick was the parent function. We have sine. And why do like, why can't we just use the right shift and the old stuff that the old transformations we've had? Like, in particular, look at this here. So there's, even with a parabola, that I often see mistakes with the horizontal transformations. Like, most people would know this is up 4. Okay, up 4. But then here, once you practice some, we get that negative, like, all right, we do the opposite, so we think right 21. But notice when we went right 7. It's because, especially in trig, like, this whole bx minus c part here starts to play around with where exactly this periodic function is going to occur. Now, even in a parabola, this actually wouldn't go right 21 because of this 3 there. But I just wanted to point out, like, kind of having an understanding it is getting shifted right, and then it is shrinking because of that 3, right? And it is being vertically stretched, which we call amplitude, and the shift up. There's many correlation between the old way of doing transformations and doing this with trig. It's just now we call certain things a little different, right? We have this amplitude and a period, and instead of a horizontal shift, we just call it a phase shift. And the last thing, if I did ask again, just like the other one, cosecant, I would still do everything I have here and then draw in everywhere where that midline was, right? Y equals 4. We had that midline. I would draw my asymptotes and then fill in the little parabola type looking things, right, in between each one, in between each asymptote, off of the max and min. And these extend forever too, even though on both of these graphs I kind of quit drawing them just so we got 2 full periods.